Hello, this is Kali Gonzalez with MLC CAD Systems, and welcome to the overview of the SOLIDWORKS surfacing certification for the sample exam. So this is actually an advanced exam. It is the CSWPA surfacing. So this entire video in this exam is making the assumption that you have already taken and passed your CSWP certification. So if you have not, please keep in mind that this actual test is not going to be available to you until the CSWP has been passed. I do have an overview video on that. You're more than welcome to check that out on our MLC CAD YouTube page. What I'm going to start out with is locating the sample exam. I'm going to go into a browser and click on SOLIDWORKS certifications, and the link at the top is where I'm going to find my certification landing page. This is going to give us a list of all of the different types of exams that we have access to. So if I scroll down a little bit, I can locate the surfacing exam. And I will click on the button called Exam Information. This is going to provide further details specific to the surfacing exam. If I scroll down, I can see that the live exam will have a length of 90 minutes with a 75% passing grade. I recommend that you take a look at this list of features that you are expected to know for the exam. All of this is fair game on the live exam, and they do expect you to have a pretty good understanding of all of these features. Further down, I'm going to click on my sample exam. Now, before we continue, I do recommend that you actually take the sample exam as if it were a live exam before you view the results. The main reason for that is if you see the results first and then you take the exam is significantly easier, and you can kind of have a false sense of security on your preparedness for the live exam. So please take this as if this was the live exam, so you have a really good understanding of what you struggle with, where you're getting caught up, or if you're good to go for the live exam. Once we go ahead and click on the sample exam link, I'm actually going to download a zip file that's going to contain the PDF of the sample exam and a SOLIDWORKS part file that's going to have an imported surface and a sketch picture that I'm going to use throughout the sample exam. So both of these are going to be provided to you inside of that zip file. On page 7 of the PDF, this is a section on how to take the practice exam. And I want to draw your attention to number 6. This is actually giving you a time range. You should be able to complete the 4 questions in the sample exam within 20 to 30 minutes. Now, something that I think is unusual about this is that they're giving you a time range. Most of these sample exams give you a specific time to be within. My recommendation to you is to be on the lower portion of this exam time. So try to be within 20 to 25 minutes. If you're running a little bit over the 25-minute mark, make sure that you have a solid understanding of anything that you got caught up on or anything that you knew was taking additional time, just because you could run out of actual time on the live exam. Going down into page 15, we have our problem description. Now, I do recommend that you read all of the information. The surfacing exam in particular gives you so much information, you have to read it all and make sure you understand the setup. So a new computer mouse is being developed. We have a colleague from another company that has developed the top mouse surface using another CAD system. And they've also supplied us with a sketch picture that's going to contain a footprint or an outline of the mouse. So we will have to open the part, create side surfaces, fillets, and other operations to complete the mouse. In other words, the end result, before we're done with the test, we are going to be turning this into a solid. Once we have an understanding of the problem description, we're ready to go on into question 1. Question 1 is going to provide us with a couple of pictures regarding what we're actually going to be creating in this very first question. What I'm actually going to do here is I'm going to scroll downward into the information provided because it's going to give us some additional context on these particular views and pictures that we are currently looking at. So as I scroll down, we have a lot of our generic information such as our units, our precision, the part origin, and any material requirements. So always take a look at this information. We are going to open up the part file provided, and it's telling us that the sketch picture is in a specific sketch named 123. That's going to be important for us to use. It's also saying create the surface on the side using either a swept surface or a surface fill. I'll talk more about that in just a couple of moments. The setup of this surface should be flush with the top plane, which is the XZ plane. The surface should start with a profile parallel to the YZ plane, which is the right plane. That's detail view AA above. So it's going to be angled 3 degrees from vertical along the boundary of the imported image. And the shape should also follow the sketch footprint. Once we're done, we will be measuring the surface area. So going back up into my views, we have view AA, which is giving us a description of the angle of the green face, which is what we're going to be creating. It's going to follow this curve on the purple face and then also the curve along the bottom. Now this bottom view also provides us with an idea of the sketch as well as the actual imported surface. This view can be somewhat confusing. You will have more context into this when we open up the actual file, but the bottom purple face is actually the sketch. It's not an actual surface body. It's going to be the sketch that we're going to use as our footprint or our outline. So when I go into SOLIDWORKS, I'm going to open up that part file that was provided to us. Once this opens, we see our model very similar to what we saw in our previews. We have a surface body and our sketch 123 has only that sketch picture inside of it. There's no other sketching items within this model. This is giving us an idea of the outline, the overall shape, so we can start seeing how these items are going to actually fit together. Now going back to the creating a surface using either a swept surface or a surface fill. My recommendation is to use sweeps, lofts, and boundaries when there's highly curved 3D surfaces involved. These do end up adhering much more closely to these highly 3D curves, and you have a lot more control over them. Accuracy is going to be important in this exam because if you have something that's kind of outside or close to being outside of the tolerance as you go through the test, you could end up with items being incorrect if any errors have been propagated through. I'm going to be using the swept surface option going forward. Now that we know kind of how we're going to approach this, this could affect how you're going to sketch these items. First thing I want to do is understand how the model is oriented relative to my orthogonal planes. So this adheres to the front plane, and the top plane is where the sketch is, but notice that the right plane does not actually intersect the model. This could become an issue if I'm planning on doing a swept surface because I need to make sure that I can snap things into that corner and I need a plane to sketch on. First thing I'm going to do is create my own plane. Again, this is going to be offset from the right plane and making sure it goes through that particular corner. Again, this is necessary for the setup of the profile of the swept surface. Once created, I'm ready to go ahead and start sketching. First thing I'm going to do is use a couple of center lines. I love using center lines to help give me geometry and to align items. I'm using a horizontal center line to make sure that any of my remaining sketches don't go beneath that, because that could end up affecting my sweep. This vertical center line is what I'm going to use for my 3-degree dimension. Now, something interesting here that you're seeing is I'm purposefully not creating a sketch relation to the end of this royal blue line. The reason for that is because I don't want SOLIDWORKS to create a coincident sketch relation, which is the default. When I start working with highly curved edges and surfaces, I use the Pierce sketch relation very frequently. The reason why I use this particular sketch relation is because when a swept surface is created, the intermediate sections are actually created much more seamlessly without as many errors. And so that's what I'm doing here is I'm using a make pierce sketch relation. The make pierce is between the endpoint of a line and a 3D curve, which is why it ends up sweeping a long three-dimensional curve so well. Once I've added that sketch relation, I still need to add in my dimension. And I will add that 3 degrees. So the profile of my swept surface is actually completed. The next thing that I want to do is sketch the outline of that curved face of the mouse using my sketch plane, my sketch as an outline for this upcoming feature. Now for simplicity, I'm going to actually hide my surface body. This is just so it doesn't get in the way and I don't accidentally create any sketch relations I don't need to. Now this is actually a 2D sketch, but I'm going to go into my spline tool in order to create this curve because it's not perfectly circular or elliptical. Now inside of this test, I typically use the regular spline tool. Now I am going to link this into the bottom of the profile. I will need to have a sketch relation there. My recommendation for you is to use a 2-point spline whenever possible. So a point on one end and a point on the other end. Notice here I'm linking up to where that looks like those points are intersecting from the sketch. Now the 2-point spline is important because when I go ahead and bring up my handles to adjust this, they adjust very quickly and very seamlessly and they match very well. Also, whenever you have a lot of extra points, you could end up with a much more wavy surface or creases, and that just introduces error into your model. Again, we're trying to reduce any type of errors like that because it could get propagated throughout the rest of the test. So 2-point splines whenever possible is one generic recommendation to create very smooth splines. There is another alternative to the traditional spline, and it's called a style spline. You could also take this existing spline, right-click on it, and there is an option to convert to a style spline. Style splines are a little bit different in how they're constructed, but again, they do create very seamless curves without a lot of waviness to them. Once completed, I'm going to actually show my surface body. I'm not quite done with this sketch and I'm still inside of my sketch. My next option here is to take the point of the spline and I'm doing a make pierce sketch relation to that curved edge of the gray surface. Again, this is going to be done in preparation for the swept surface. Once I have my spline completed, I can go ahead and hide my sketch picture, and I'm actually ready to do my swept surface. So I'm going to go into my Surfaces tab and choose Swept Surface. I'm going to choose my profile, which is that angled 3-degree line. I'm going to choose my path, and I'm going to choose the simpler path from the outline on the spline I just created. And then I'm also going to use a guide curve, which is this more curved ergonomic shape. And we can see how the surface is created that matches all 3 of those edges and sketches together. And it fits very, very well with how we did this. My recommendation at this point is to always double check your curvature of your surfaces and the integrity of the surfaces as you go. So I'm using mesh previews, zebra stripes, curvature combs. These are all built-in analysis tools that you can take a look at. Again, what you're analyzing here is to make sure you don't have any unintended waviness inside of your surfaces or anything that is a crease or a seam or anything out of the ordinary. So always double check that as you go. Now that my surface is completed, I'm going to go into my Evaluate tab, and I'm going to measure the surface area of this face in green. And if I zoom in here, I can see that the area is 2,220.68 millimeters squared. Now, if I go ahead and compare that to the answer key provided in the sample exam, theirs is 2,220.93 millimeters squared. So I'm very, very close. Notice in the answer key, they also gave you a plus minus 7 millimeters squared. So I'm definitely within that range. I'm extremely close, and I'm actually very happy with that result. So this also does show you that you need to be very close, and you should be able to get extremely close to their answers, especially with anything with multiple choice. They do give you a larger tolerance of error in this exam simply because it is more subjective, because we are sketching over sketch pictures, and it's just a little bit more of a subjective topic. We're ready to go on into question number 2. So if I take a look at the image for question 2, we will notice it looks slightly different. It has an existing fillet inside of it. So we can anticipate on creating some type of fillet. And the actual question tells us to create a curvature continuous fillet surface that connects the top and side surfaces. The actual fillet radius is going to be 3 millimeters, and it's going to travel the full length between the top and side surfaces. We're still looking for the surface area, and they're giving us a plus or minus 10 millimeters squared kind of error tolerance here. So quite a bit of information. I think what can throw you off in this particular question is the curvature continuous. There's a very fast way to make this type of fillet though. One of the first things that we're going to do inside of SOLIDWORKS is I need to actually merge both of these surface bodies into a single surface body. I cannot actually create a fillet as this is right now. It would just produce an error. So I'm going to use my knit surface and merge these two surface bodies together. I'm still working with the surface, but now notice that it's one surface and I have a black seam in the middle instead of a blue. Those blue edges indicate a surface. So when I have an actual corner like this, I can use my regular fillet tool in order to create a fillet even on surface bodies. Under the fillet type, I am going to keep this on a constant size fillet. And as you take a look at this, you might also not see anything obvious as far as making it curvature continuous. So once we update the actual fillet size, I'm going to be able to choose the specific edge. And from here, under the profile of the fillet parameters, this is where you are actually going to see the specific setting for curvature continuous. Again, if you didn't realize that this was there, this is one of those questions that you could end up wasting a significant amount of time on when the fillet already does this for you. So this is one question where there is an anticipation that it's going to go by very, very quickly. If I go to my Evaluate tab and I measure the surface area of the actual fillet, what we're going to notice is that we're at 348.46 millimeters squared. Now, when we compare this to the actual multiple choice question, we are extremely close to the answers provided, so I can confidently choose B. I am by far closest to the B in the multiple choice question. Again, once we have this established, we are ready to move on into the third question of this exam. Now, if I take a look at the image provided, we can see that we're going to define a specific length and then also an angle at the front of the model. So there's a couple of changes that we will have to make to our existing model. It's just telling us that we're going to trim the end of the mouse. So trim the surfaces at the end to 5 degrees while keeping the length of the mouse at that 115 as shown above. And then we will remeasure the top surface. So they're specifically mentioning the 115 and the 5 degrees is what we're going to apply and change into the model. Going back into SOLIDWORKS, one of the first things that I know that I need to trim a surface is either a sketch or another surface. Those can both be used as trim tools. I'm just going to use a sketch because it's just as effective in this case and it's much, much faster. So I'm just going to open up a sketch on the front plane and I'm going to start with a center line in order to establish what the 115 is going to look like, because right now I don't really have a good idea of that, considering this was imported. So we have that 115. Again, I'm going to use a center line to create a vertical line and just make sure that this extends above the surface itself. This is an instance where the lines may not need to be fully defined. I just want to make sure it's going to be above the surface, and I'll set that to an angle of 5. Once this is completed, I am ready to exit my sketch. And in my Surfaces tab, I'm going to choose my Trim Surface feature. Now, if your sketch did not automatically populate, you can always select it by going into your flyout tree and choosing it there as well. From here, I can choose what I want to remove or keep based on which is easier. I'm going to choose items that I want to remove, and I can just hover over the left-hand side, and that section in purple is actually what is going to get trimmed based off of the sketch information that I've provided. And as I click OK, I am ready to measure the top face of this model, and that is 3,724.41 millimeters squared. Comparing that to the answer key of 3,723.81, I am extremely close. Notice also they gave us a plus or minus 40 squared millimeters. That's a pretty large gap, but again, I'm very, very close, so satisfied with how my surfaces are looking so far. Going on into question 4, this is the last question in the sample exam. The images providing to us show that the bottom and like the front face looks like they're closed in. Normally with surfaces, our end goal is to have a solid body. And if we take a look at question 4, we were correct in that assumption. We are going to complete the solid. This also gives us material that we're going to apply in order to get the mass. But notice also this tells us to mirror the existing surfaces and then complete the steps to make it a solid. So the mirror is something you want to pay attention to because it's actually indicating that this is going to be perfectly symmetrical. And then the test is assuming that you know the steps and what is required to make a surface a solid. Going into SOLIDWORKS, we're going to mirror the surface first. Now remember where our front plane is located. We notice that at the beginning, it's already in a position that I can use it to mirror. So I don't need to create any additional planes or anything like that. I can go into my mirror tool, choose my front plane, and now remember that we are working with surface bodies. You need to choose bodies to mirror in this instance in order to select the surface and mirror those. I'm also going to choose my knit surfaces option. This is just going to merge both of these surfaces into a single surface in conjunction with the mirror. So it's allowing me to skip some manual steps. So once completed, we still have to fill in the bottom and the front side. Now the next thing that I'm going to do, would not necessarily need to be required for the exam, but it is something that if you have time, it doesn't really consume a whole lot of it, and it would be a recommendation that I would make. I'm actually going to go into a three-dimensional sketch. Three-dimensional sketches are items that are part of the exam that SOLIDWORKS anticipates you're going to know about. Inside of that 3D sketch, I'm going to take that curved portion that I just highlighted and convert it into a seamless spline. So going into my three-dimensional sketch, I'm going to first use convert entities to make those edges of that surface into an actual sketch entity. When doing this, also make sure that you select all of the smaller faces as well. If you miss any face, it could affect the end result. Once this has been converted, I'm going to use a feature called Fit Spline. Fit Spline is not on your command manager by default. You may have to use your search tool. But what this does is it takes an existing group of sketches like these converted sketches, and it extremely closely fits a spline over on top of them. What this allows us to do is when creating surfaces, it reduces any additional seams or any intermediate sections that could reduce the accuracy of that particular surface. That's the one main reason why I tend to do that, especially when I know there's not going to be a seam required. I still need to close this off because I am going to use the filled surface, so I need all of my boundaries to exist. So this is just a two-dimensional line. Now this next surface is actually a very good example of using a filled surface. At this point, I'm not even 100% that this is going to be completely planar. I don't think that it is because of how the surfaces are kind of transitioning at the end. So I'm going to use my surface fill, choose my fit spline, and that two-dimensional sketch. And notice how nice of a surface this provides me. Again, always double check with things like curvature. Black is an indication of no curvature or extremely low amounts of curvature. There is some curvature on the sides, but again, I didn't necessarily anticipate on this being 100% planar. So I don't think that's enough to reduce my accuracy. So always double check your surfaces as you're going throughout the exam. I have one more surface that I need to do, and that's to fill in the bottom. So I could also go through the same fit spline sequence as well. It is something that's kind of over, above, and beyond. There may be situations where I will do that if there's like an excessive amount of small faces or segmented edges. But in this case, even if I don't do that, I still get very nice cohesive edges and surfaces. Under the options, now that this is completely enclosed, I have an airtight, watertight volume, I can use my options to merge the surfaces together, and then I can also click on the button to create a solid. Again, doing it within this property manager actually reduces a lot of manual steps, which is why I'm doing it here. So this gives me one solid body. I have no more surfaces inside of this part file. I'm going to add my material. Now this material is going to be found in the plastic section under ABS. Once I have added that material, my mass properties will give me the mass of 176.27 grams. Again, comparing this into the answer key of 176.87 grams, I am definitely within that 3.5 gram error tolerance. Part of the reason why my results were so accurate in this exam has to do with me using a swept surface at the beginning. I had actually done this test twice, and the first time I did it as a filled surface for that initial side, and when I got to question number 4, I was ever so slightly within tolerance, but I could have easily been out if I would have had an additional question where I had to edit something. So that's something you really need to be aware of with the surfacing test. Try to use sweeps, lofts boundaries whenever you can with things that are highly curved. Use the filled surface to fill in remaining surfaces and things that are relatively flat as well. That does bring us to the end of this sample exam. Again, I hope that you had a lot of good tips and tricks. This test is a little bit longer in terms of me talking because there is a little bit more to explain. It's a little bit more subjective. But if you do have any questions about this video, about the exams, the certifications, anything, please reach out to us at mlc-cad.com. I want to thank you for your time and good luck on all of your testing. Have a great day.